welcome to this lecture, and we have in the previous class covered the human centered design, and as far as summary of this basically this previous lecture, we have covered introduction to human centered design, and we have sort of illustrated anthropometry and description of various dimensions of the body. So, this is the lecture in continuation with the previous lecture. So, just have a recall of a previous lecture that we have discussed about anthropometry. So, this anthropometry is a word which is derived from two Greek words, anthropos and metron. So, it means that measurement of human body. So, these anthropometric data which means that data which we have obtained from the measurement of human body is used in ergonomics to specify the physical dimensions of the workspaces, equipments, vehicle, any system design, just to ensure that these products physically fit their users. So, in most of the cases we have to perform analysis, and we require some statistical analysis. So, in that first before designing for the population of users, we have to take care of the kind of majority of the people in that population. So, first we have to specify the user population and then design to accommodate as wide as range as possible. So, normally 90% of the users. So, why this particular 90% we have taken? So, we will discuss these things in detail. So, as far as statistical measurements are concerned, so this anthropometric variables usually follow a normal distribution curve. So, this anthropometric variables follow a normal distribution curve. So, now we will understand what this normal distribution curve is all about, and what is the importance of this normal distribution curve in order to analyze any anthropometric data which we have captured with the help of measurement of various parts of the body as per the requirement. So, this particular curve has a mean and a standard deviation. I will speak about the formula with which we can calculate this mean and standard deviation. So, there is a mathematical formula to calculate mean and standard deviation from normal distribution curve. I will discuss about that, and the fact is, the more individuals that can be measured in an anthropometric survey, the more accurate the estimates will be. So, as statistics known as standard error of the mean, that we denote as SE in this lecture, is calculated to enable accuracy to be estimated. So, that standard error is calculated with the help of this formula, that is SD stands for standard deviation and N stands for the number of people measured in the survey. So, this standard error and its related applications I will tell you in the forthcoming slides. So, this is majorly we will be covering here in this lecture. So, this anthropometric variables in a healthy population usually follow normal distribution curve. So, here in order to understand normal distribution curve in a much better way, so there are two key parameters of the normal distributions, which are mean and standard deviation. What this mean is all about? This mean is the sum of all the individuals in fact all the individual measurements divided by the number of measurements. So, it is a measure of central tendency. And now, how you will calculate the standard deviation. So, that standard deviation is calculated using the difference between each individual measurement and the mean. So, I will give you the formula of the same also. So, it is basically calculated with the help of a difference between each individual measurements and the mean. So, basically the value of this standard deviation determines the shape of the normal distribution. This small value of standard deviation indicates the small value of standard deviation indicates the most of the measurement are closer to the mean value. And a large value of standard deviation means that measurements are scattered more distantly, we can say, from the mean. So, the distribution will be having a flatter shape. So, now this is the normal distribution representation, where you can see this particular nature of the curve, and the formula with which we can calculate this mean and standard deviation, which I am writing here. So, in order to estimate the parameter of several dimensions or stature in a population, it is necessary to measure a random sample of people who are representative of that particular population. So, the formula that we can use to calculate the estimates of the mean and standard deviation are as follows. So, if we have to calculate mean, so the formula to calculate mean we are denoting as x bar is sigma from I equals to 1 to n x I in the denominator n, and the formula to calculate standard deviation is, if we are denoting standard deviation as SD, so these are the equations which we use to calculate mean and standard deviation from the measurement sampled from a population where x is the individual measurement and n is number of measurements. So, the mean, in the definition wise we can state that the mean is the sum of all measurements. So, mean is the sum of all the measurements divided by number of measurements. And as far as the definition of a standard deviation is concerned, so standard deviation can be defined as the square root of the mean squared difference between, let us say, each score and mean. So, here in this normal distribution curve, an important characteristic of this particular curve is that it is symmetric, as many observations lie above the mean as below it. So, so the right of the mean is equal to the left of the mean. So, if a distribution is normally distributed, so 50% of the score will lie on either side of this particular axis. So, in this way we plot this normal distribution curve, and nature of the variation of the number of populations or number of users. So, this is in more detail this properties of normal distribution curves are. So, just have a brief idea of this particular curve is. So, the properties of the normal distribution curve. So, the normal distribution curve is symmetric about the mean, that I have told in the previous slide. That is 50% of the value lie above the mean and 50% of the values lie below the mean. Because the mean divides the distribution in half, the mean is also the median. Because the maximum point on the graph occurs at the mean is also the mode of distribution. So, the one more interesting point is that 100% of the distribution lies below the curve, the total area below the curve is 1. So, the area that is covered by this particular curve is 100%, means all the data are lying in beneath this curve. So, the total area is assumed as a, and it is 100%. So, total area below the curve we can take it as a 1, and approximately 68.3% of the distribution lies within one standard deviation of the mean, that is the area below the curve between x minus sigma and x plus sigma is about 0.683, that is 68.3%, and about 95.4% of the distribution lies within 2 standard deviation of the mean. So, that is the area below the curve, that is x bar minus 2 sigma to x bar plus 2 sigma. So, about 0.954. So, the area below the curve between x is equal to a and b, if you take any area of the particular curve which lies between the point A and point B, the probability that a given x value will lie between A and B. So, this particular p is the probability. So, now this is all about the rough idea of normal distribution curve, and these things will be more clear when we solve numericals. So, now the next thing that we need to learn in this anthropometric analysis is the calculation of percentile. So, we will learn how to calculate percentile value of the body dimension. So, any percentile may be calculated if mean and standard deviations are known. So, there is a formula through which you can calculate percentile of a variable, let us say x. So, xp, so pth percentile of a particular variable x can be calculated with the help of the sum of mean plus standard deviation. So, SD is the standard deviation, m is the mean, and xp is the pth percentile. So, now if we have known that how to calculate this mean and how to calculate this standard deviation. Now, the question is, how can we calculate this particular z, and what is this z and how we can calculate this value in order to evaluate the percentile. So, z is the basically z is the constant for the percentile concerned which we look up in the statistical table. So, generally this z score we calculate with the help of a table. So, before that we have to know that there is a difference between a normal distribution curve and standard normal distribution curve. If we will be able to know the difference between these two, we will be able to calculate this z score, because for different values of z under the curve of a normal distribution we have separate values. So, now we will try to understand the difference between normal distribution curve and standard normal distribution curve. So, this normal distribution curve, as we have learned in the previous slides, that it can be described by the mean and standard deviation. So, the value that is calculated as the mean we plot in the middle of the curve, that is, let us say if it is y axis and it is x axis. So, then the middle of the curve where half of the portion is lying on the left side and half of the portion, remaining half of the portion is lying on the right side. So, here we plot it as a mean, and as per the standard deviation we calculate. So, we go beyond this particular y axis. So, these are the standard deviation values through which we deviate from the mean of the particular curve. So, now the difference between this normal and standard distribution curve. So, we have to standardize and bring this curve to this particular status, where this status is like that instead of plotting a particular mean value, we plot it in the mid of the particular curve as a 0, and with that 0 with respect to this particular point we calculate the standard deviation and that we known in a normal distribution curve as a z score. So, these are the instead of, so if heavier data are there, so it is not for complex situations, it is not mathematically convenient to have a record of these huge numbers. So, rather than this we convert this particular normal distribution curve as this. So, we as a median, we in the mid of the point of the curve we take it as a 0, and the deviation that has been occurring we plot it as a 1, 2, 3, or in a lesser numbers, that number is known as z score. Now, the question is how can we calculate this z score and how can we brought this values as a lesser numbers. So, here so the difference between this normal distribution and standard deviation is that the total area under the curve under the this basically under the whole standard normal distribution has a value of 1. That is obvious for both kind of curve. So, by definition, as z increases, distance from mean increases, and the area under the normal curve in fact to the left of z also increases. So, how we will calculate this z score? So, there is a formula through which we can calculate this. So, z equals to x minus x bar upon this s d. So, this is the formula through which we calculate this z score, where x is the normal value. So, normal value or any value of x, this any x bar is the mean, and this particular thing is standard deviation, as you now have been aware of the fact. So, we have to put in order to calculate this particular values, that is z score, we have to calculate, first we will have to calculate this mean and standard deviation. So, then we can plot the different values of z score, which can be plotting somewhere here depending on the particular value of x. So, this is the particular formula through which we calculate the z score, this x minus x bar upon s d. So, in any anthropometric survey, the more individuals that can be measured in an particular survey, the more accurate the estimates will be. So, in that context, the statistics known as standard error of the mean is calculated to enable accuracy to be estimated. So, if standard error is SE, so that we can calculate with the help of standard deviation, and in the denominator square root of n. So, where SD is the standard deviation of the mean, and n is the number of peoples measured in any survey, that is anthropometric survey. So, let us have a one example of this particular formula through which we can estimate something that is really useful to learn. So, for example, if the mean stature means any height or any length. So, mean height in a sample is 1750 mm, let us say, and standard deviation to 100 mm, and number of people have been measured as a 100. So, the standard error will be, in this case standard error will be standard error of the mean, in fact, will be 100 upon square root of 100. So, that will come out as a 100 upon 10 equals to 10 mm. So, let us take another case where suppose we had measured 10,000 people. So, it means the value of n will be 10,000 and the mean and the standard deviation were the same as the previous case. So, the standard error of the mean will be what? It will be standard deviation is 100 and number of people involved in that anthropometric survey are 10,000. So, that data will be coming out as a 100 upon 100 and it is 1 mm. So, as you can see that here if the number of people involved is 100, so the standard error that is coming as a 10 mm, and if the number of people in the survey are involved as many as 10,000 people, that is n equals to 10,000. So, standard error is minimized to 1 mm. So, now you can see this picture that as it is you can predict a particular information from these two examples, that more and more individuals if they are involving in a particular survey, the lesser will be the standard error. So, there is a statement that you can make from this particular example, that larger samples enable us to make accurate predictions about population parameters. So, that is why in any anthropometric survey the number of people should be more. So, for ergonomic work involving the main body segments, centimeter accuracy is sufficient because of the uncontrolled variability due to let us say clothing and circadian variation in stature and other factors which change the shape and size of the body. So, sometimes the very large samples probably are not needed. So, more important is to ensure that the sample is representative of the population of interest. So, that is the overall estimation of a standard error of the mean and the illustration of the normal distribution curve. Now, let us have another example which we will try to solve, and the learning that we have obtained from this particular slide, that how to calculate z score and this mean and standard deviation. So, we will try to solve examples and try to find out how you can calculate the z score with the help of this formula. So, now we will solve one example which says that a survey of daily travel time had these results in minutes. So, 26, 33, 65, 28, 34, 55, 25, 44, 50, 36, 26, 37, 43, 62, 35, 38, 45, 32, 28, 34. So, these are the results that has been obtained by the survey of daily travel time. So, these are the travel time, and now we will have to calculate the mean, standard deviation and z score, so that we could have a clear understanding of about the normal distribution curve and which can be drawn with the help of z score. So, now first how we will calculate the mean. So, mean is the formula for mean is clear. So, that is to calculate mean, formula is x bar equals to xi upon n. So, in this way we have to where this I is the number of the travel times. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So, I equals to 20, and in this way we can calculate this particular mean as a 38.8 minutes and the standard deviation is 11.4 minutes. So, this is the formula to calculate mean, and for standard deviation we have another formula. summation of I equals to from I equals to 1 to n of a number of surveys or number of terms that have been taken by the mean minus difference as the mean and upon n minus 1. So, with the help of these two formulas we can calculate this mean and standard deviation. So, now since we have another formula to calculate this z score that we have learned from the. So, z score is calculated with the help of x minus x bar upon standard deviation. So, for this particular value, so we have to calculate individually for each particular values the z score. So, for let us say 26, so z will be 26 minus, so mean is the x bar and standard deviation is the SD. So, x bar is the 38.8 upon standard deviation has come out as a 11.4, that will be some value. Similarly, for 33 you have to calculate z score, which will be as a 33 minus 38.8 upon 11.4. So, that will come out as some value. So, in the similar way you will have to calculate for each number, let us say for 65 you will be having, if I am giving as a z1 z2, so it will be z3. So, that this will be some value. For 28 the value will be something different. So, in this way for each particular value you will be having a distinct z score. So, we will have to convert this particular. So, this is the solution that I have already written here. So, that is convert the value to the z score, that is known also as a standard score. So, to convert 26 you have to first subtract the mean. In fact, these all the sentences that I have written, it is just to calculate the z score with the help of this particular formula. So, again you will divide the standard deviation as minus 12.8 to 11.4, which will come out as a minus 1.12. So, 26 is minus 1.12 standard deviation from the mean. So, this is calculated value which has come out as a for 26, that is for this particular 26 the value is minus 1.12. So, this value you will plot in that particular normal distribution curve as a deviation from the mean. So, this is the z score for plotting standard normal distribution curve. So, now let us say for the first three values were 26, 33 and 65. So, I have calculated this value as a original value and its calculation as this, and standard score has come out as a minus 1.12. For 33 it has come out as a minus 0.51. For 65 it has come out as a plus 2.30, so on and so forth. So, this you have to keep on calculating the value for each travel time, and up to 20 numbers you will have to calculate the each value of z score. So, then after calculating the z score you will have to plot in the normal distribution curve. So, as it is clear from the definition itself of a standard normal distribution, that you will have to put 0 here, and how much deviation, let us say if you have to plot in the x axis for each travel time. So, for each travel time there must be one z score. So, that you will plot, and in this way. So, let us say if it is lying in the, I am not it is not exactly same as the score that we have predicted, that is just a notation I have used. So, something like that. So, here also the negative values will be plotting here and the positive values will be plotting here. So, that will be as you can see from this figure also, that's plus 1, plus 2, plus 3, these are the z score, and these are the possible values. So, if you are wanting to plot a normal distribution curve, in fact standard normal distribution curve. So, you will plot it in the form of z score. That z score you will calculate with the help of the formula that I have given in the previous slide, and as far as normal distribution curve is concerned. So, you will plot in this particular let us say origin, here you will plot the mean and the deviation in the left and right side. So, that is the case. So, this is the value for a standard normal distribution curve, this is a standard curve, and this is the normal curve values. Okay. So, this is the difference between the standard and normal distribution curve. So, why we are plotting here, because in the later stages of while solving anything, any numerical, you will be requiring this particular curves assistance. So, I have put one table from a book written by R.S. Bridger, that this is a table of probability associated with the values of z in normal distribution. So, what is indicating that it is generally while solving a numerical, this particular table is given to you. So, in order to make your calculation fast, and you can choose that particular z score value from this only. So, just I am picking one example in order to understand this particular curve. So, here is a z score, if it is coming out as a 0. So, the area which is going to cover is 0.50. It means that this particular value is indicating that if z score is 0. So, this is in the x axis we are plotting as a z score. So, this is 0. So, correspondingly the area will be 0.50. It means the 50% on the left and 50% on the right. So, that is z score is also used for prediction of the how much area that particular standard normal distribution curve is covering. So, in this way these are the z score values that and correspondingly the values are given. So, in this way you can calculate the probabilities of the area covering in this particular curve. So, now in most often if you will read any book and if you find something written as this particular notation, like some number, let us say some number, let us say like 1740, and in the large bracket something is written. So, it means that the digit written outside the bracket will be indicating the mean of that particular user population or measurement, and in the bracket the standard deviation is mentioned. So, that is why I have written this statement that stature of a man is 1740 in bracket 70 mm, which means that stature of British man is normally distributed with a mean of 1740 mm and a standard deviation of 70 mm. So, this particular notation is indicating that the first kind of digit is mean, and in bracket that digit mentioned is standard deviation value. So, now we will take another example, and so that the more clear understanding towards the calculation of percentile could be developed. So, suppose we wish to calculate the 90th percentile of the stature of the male adult Indian population. So, there I have put one table for you, so that the immediate z score value can be taken for our kind of calculation. So, from the table we can see that corresponding to p equals to 90, there is a z score value 1.28. So, we have the formula is known. So, it is very much easy for us to calculate this particular thing. So, as you can recall from the previous slide, we have gone with one formula, that is this one. So, xp equals to m plus z times standard deviation. So, that formula we will use in order to calculate the pth percentile. So, that formula was xp equals to m plus z times s into d. So, that was the pth percentile and m was mean, z was z score, that we have now understood how to calculate this particular z score value, and SD is obviously standard deviation. So, now we have to calculate the 90th percentile of the stature of the male adult Indian population. So, first we have to see that here the what things are given as p equals to 90. So, this formula is used for calculating the particular value of the percentile. So, now this table is given, this table is is giving the values of z for selected percentile. So, here is the percentile, like these are the percentile values and these are the possible z score values. So, let us say if 99th percentile if you are talking about, so it is indicating that its z score value will be 2.33. So, taking the values corresponding to this table, we can evaluate from this. So, we require the 90th percentile value. So, here we have to find out the 90th percentile. So, corresponding to 90th percentile, the value of z score is 1.28. So, now we will take this value. So, from the table we can see that p equals to 90, z equals to 1.28. So, this means that 90th percentile is greater than the mean by 1.28 times the standard deviation. So, here we will put these values, like mean is given as a 1740, z score is already taken from the table, that is 1.28, and standard deviation is written here in the inside that bracket. So, this is 70. So, 1740 plus 70 into 1.28, which will give you 1830 mm. This is the 90th percentile value of the stature of male adult Indian population. Again we will solve one more example, so that the things could be cleared out in a much better way, so that we can also we could also learn how to use this table which will give you the probable value of z score. So, now the question is, we have to estimate the 5th percentile popliteal height of the Indian male. So, how you will calculate that? If the table is given, so in that, so so how you will calculate the 5th percentile? Like again you will use the values given the table and the mention and the formula that we have used in the previous slide, that for a particular let us say pth percentile, the value is calculated with the help of mean plus standard deviation times z. So, so mean is 415, standard deviation is 21, and correspondingly corresponding to pth percentile, the value is, value of the z score is what? So, we have to, the required percentile is given in this table. So, 5th percentile is, the area to the left of z is 0.0505 and the corresponding z value is minus 1.64. So, this value is of our use, and this value we will pick up from the table and put it here. So, m is the mean. So, it is 415 plus standard deviation is 21 into minus of 1.64. So, here the value will be coming like when you multiply this 21 and 1.64, it will come out something like 34.4. You check this value and subtract this to this. So, you will be getting tentatively like 380.56. So, this particular value you will be getting. So, in this way the things are clear that how you will calculate the percentile value of any particular user population when the mean and standard deviations are given, and in the table z score will be given to you. So, now the next question is which is again just for the practice. So, the 95th percentile value of a normal distribution variable is found by adding 1.64 standard deviation to the mean. So, if the mean body mass of the males is 82.1 kilogram and the standard deviation is 17.1 kilogram, what is the 95th percentile body mass? So, here again we will use the same formula, that is so here the things are given like mean body mass is 82.1 plus this particular value is given like it is itself is given. So, you can just have to make a sentence in the mathematical form. So, you can easily convert this particular sentence in the mathematical equation that is found by adding 1.64 standard deviation to the mean. So, it is something like 1.64 into mean is what, in fact standard deviation is what, 17.1, that will come out as a 82.1 plus 28.04 something, and it will come out like a 110.14. So, this is the these are the questions that could be emerged out from this particular theoretical domain. And again there is one more question. Now I am giving this particular question to you, it is much more similar to those what we have solved. So, you can note down this question as well and you solve by your own mind, and the answer will be the answer that you have to solve. So, the 5th percentile of a normally distributed variable is found by subtracting 1.64 standard deviation from the mean, and if the sitting height of the females is 861 mm and the standard deviation is 36 mm. So, what is the 5th percentile sitting height? So, that question is I am giving to you, you just solve it and practice it. So, now there is a one table that I have taken from MP Groover book that will give you the standing heights of the males and females throughout the world. So, that is a very interesting data that you can check here, that there is a table of male and female and there is a region discrimination here. So, here you can see that these are the anthropometric data basically which is compiled from the population, and this usually this can also usually follow the normal distribution curve. So, this data you can see here that North America is having the highest, not highest, but it is 179 centimeter. Northern Europe is having height of the male as a 181. So, these are basically these data are usually published not only to list mean values, but also to reveal the dispersion and the distribution. So, the Central Europe is 177 and Southeastern is 173, Indian North is 167, is 162, southern part of the India mostly contained. So, this is the data. So, you can have a difference between the standing heights of male and female throughout the world. So, now we again go to the next topic, that is anthropometric design principles. So, those design principles are design for extreme individuals, design for adjustability, design for average user, design different sizes for different size users. So, basically these are nothing but the principles and guidelines which have been developed for applying anthropometric data. So, all the products anthropometric data in design. So, there are basically variety of designs, and that design variation is because of the human size variability, and that human size variability we have discussed in the previous slide, which is basically and mostly based on the age and climatic conditions where the people are living, and various ethnicity is also one of the major factors, and climatic conditions, age, sex, health conditions, and these are the possible factors of the human size variability. So, as far as age is concerned, so a person having age of 20 to 30 is having a difference in in its height or in the dimension of various parts of the body, which will be different to the person having older age or the child having less than 5 years of age. So, that is why these 4 principles have been discriminated based on that human size variability. So, design for extreme individuals, it indicates that the height or the measurement of a tallest person will be surely different from the person who is the smallest in height. So, these are the extreme cases. I will give you the examples of these distinct principles through which this anthropometric design has been described. Design for adjustability. So, the products are designed so that certain features can be adjusted in order to accommodate a wide range of users anthropometric dimensions. So, design for adjustability, you can think of any example. You can take an example of automobile driver seat that is adjustable, and any chair if you can think if you can visualize in your surrounding, so that height is adjustable. So, that is also one of the kind of examples which you can take in this category of design of extreme design for adjustability. So, as far as a design for the average user is concerned, so average user is so average user as an example you can take of the persons who is having age of let us say 25 to 45, where the body posture does not change so much. So, this particular age group you can define in that particular average user, and the all sort of, if you can take example of clothes and all. So, these clothes are fitting in that particular age group. So, average user is those age group where designing is considered. In that, design different sizes for different size users. So, the important examples of these situations may be shoes you can take, clothes that can also be considered in the designing of different size for different size users, because clothes designing is different for different age groups. And obviously, chair for students you can take chair for students, especially in elementary school. Thank you.